Today we're going to be talking about some circuit basics. So we're going to go over what current and voltage are, how they're measured, and how to use a multimeter, and the application of Ohm's law. So first we have to know what voltage and current are. So voltage is the force that makes electrons flow. This can be mathematically written as V equals dW dQ, which is the voltage is equal to the small change of energy, which is dW, over the small change of charge, which is dQ. To add to knowing what voltage is, we also have to know current, which is the rate of flow of electrons. This is shown by the expression I equals dQ over dt, where dQ is the rate of flow of the charge per unit time. And then both current and voltage hold a place in Ohm's law, which will appear later. So the first part in being able to measure current and voltage is building a series circuit. I built the circuit that I drew on the right side containing 3 resistors, a power supply, and a breadboard. And the power supply carries around 9 volts through the whole circuit. The series are placed in series with one another. The resistors are placed in series with one another. So in the picture of the breadboard, the current is not complete because the power supply probes are not connected to the resistor R1 on the left and R3 on the right. The resistor should not touch, but must be connected through the breadboard. So for example, R1 is placed in E20, and then the left of R2 is placed in C20. And so that's shown here. This is E20 and this is C20. The power supply is going to go to the left side of R1, and the other power supply source is going to go on the right side of R3. So now we can start setting up the multimeter to be able to measure voltage. So the leads have to go in the right ports. So we have 3 port options. So the black or negative probe goes in the COM port, which is in the middle of my multimeter, and then the red or positive port wire will go into the VA port. Then you have to turn the dial to what you want to measure. So we want to measure voltage of the resistors in the series. So we're going to turn the dial to V, so that's on the left on my multimeter, and I put the setting to 20. If measured correctly, the total voltage of all the resistors combined, so the sum, should equal the amount of voltage that was put through the circuit from the power supply, which is roughly around 9. So here I measured each resistor, the voltage in each resistor. So I added alligator clips to my resistor probes to make it easier. So I connected, you can see I used white and green alligator clips that are connected to my multimeter probes. Once the power supply is on, so I also connect my power supply using the black and red alligator probe, alligator clips to the resistors. Then we're going to add the alligator clips from the multimeter. So as you can see, the black and red are from the power supply, the white and green are for the multimeter. So once I connected those, I waited for the multimeter to level out on a number. So the voltage for R1, I ended up getting 3.29 volts. So then I did the same process for R2. So I moved the alligator clips to R2, so one on each side of the resistor, making sure they're not touching each other or the other resistors. So then for R2, I waited until the multimeter settled down, and then I got V2 equals 4.75 volts. Then I also did the same process on R3 because I did a circuit with 3 resistors. Then I did the same process, making sure they're not going to touch, move the alligator clips to resistor 3 on each side of that resistor, waited until it was done, and then R3 equals 1.05 volts. So then you can double check your quantities for each resistor by double checking with the calculation, which will be the sum of the measured voltages should be equal to or close to 9 volts, which was what my power supply was putting through the circuit. So if you do the sum, you're going to sum up all the voltages together. So 3.29 plus 4.75 plus 1.05 volts, which equals 9.01 volts. So from my previous drawing that I did, the power supply was at 9.1 volts. So that checks out, and that's all good because they should equal each other. Then we're going to do the same process again to measure current, but we have to change the multimeter settings. So we're going to do the similar process to voltage, however, we're going to measure current. We have to set up the multimeter so that the dial is now on the current side. So then I moved my multimeter dial to the right, which measures current, and then I placed that on 10. The leads will then be placed just like we did when measuring voltage on each side of one resistor, and then I moved it to the second resistor and then R3. So if this process is done correctly, the current should remain constant throughout the whole series circuit. So now we're going to look at actually measuring the circuit. As you can see, I put the leads of the multimeter and the alligator clips on each resistor, and as you can see, I do not have a power supply on this one, because if you have the power supply, you'll end up burning through your resistor, and you don't want that. So you don't use the power supply, and you just put your alligator clips on each side of the resistor, making sure they're not touching. So for I1, I ended up getting 8.9 amps. Then I do the same process on R2. So I wait until it's all leveled out, and I got 9.1 amps. Then I move those alligator clips to R3, and I got 8.9 amps. So as you can see, they're all relatively consistently the same. So as you can see, the current stays consistent throughout the whole circuit in a series circuit. Lastly, we're going to talk about Ohm's law. Ohm's law revolves strictly around resistors. So if you recall, earlier we measured voltage and current. Ohm's law is mathematically expressed using V equals IR, which is the current that flows through a circuit or circuit element, which is directly proportional to the voltage V applied to it. So as stated, this uses voltage and current, which we already measured. For the equation V equals IR, we then have one unknown because we already measured voltage and current. So we don't know resistance. Moving variables around, we then can move from V equals IR to R equals V over I. So I just changed the variables using simple algebra. I did calculations to find the resistance of each resistor using the measured values from earlier. So using R1, we knew that the measured voltage was 3.29 volts, and then the current was 8.9 amps. So you can put it in your equation to do 3.29 divided by 8.9, and that will equal R1. So R1 equals 1.011 ohms. And then I did the same process for R2, which V was 4.75 volts, and I was 9.1 amps. So you do 4.75 divided by 9.1, so that gives you the resistance of R2 in ohms. Then do the same process for R3. So to go over everything that we learned in this video, we learned what voltage and current are, how to use a multimeter to be able to measure voltage and current, and then went over a little bit of the uses of Ohm's law. So Ohm's law is V equals IR, voltage, current, and resistance. So if you have voltage and current, you can calculate resistance. Or if you have current and resistance, you can measure voltage.